Blum Novatest have got this wonderful new facility here in Burton-on-Trent. I'm going to be talking with David Mould, their Managing Director, who's going to be discussing their wonderful suite of products.
MTDCNC, bringing you the latest engineering news via video media.
David, we're in this new facility. What's been happening over recent years at Blum?
It's been very successful. We've grown the UK subsidiary quite substantially, which is why we've now moved to this new facility in Burton-on-Trent, which gives us the ability to demonstrate the products and carry out training. But generally, the UK subsidiary has grown over the last few years. We've got more people working here, and yeah, things are looking up. It's looking good.
What's the demo we're going to see today?
We're going to show three products essentially today. We're going to start with the TC50 spindle probe for workpiece inspection. Then we're going to show our kind of flagship product, really, the laser control for full tool inspection and setup.
A common argument from an engineer is, why would I measure my parts on the machine when that should be making parts, making swarf? Why not use a CMM?
Yeah, absolutely. This is the common thing that we come across, really. There are applications, there are customers where it will always be better for them to measure off the machine, but there are certain applications where there are big advantages to making sure that you control the process and you get everything right first time on the machine. If you think of customers that are producing high-end components, to take it off the machine into a CMM or an inspection area and then check it and find out that you've got a few issues, you might need to come back and rework it. It's not always possible to rework, so in some cases completely impossible to reset the part up again. So it gives you big advantages with doing it all on the machining process.
There's a similar argument with tool measurement as well. Could we not use a presetter away from the machine?
Yes, you can, but the advantage you've got is of measuring your cutting tools on the machine, again, is your productivity benefits, that the speed that can be done. You're taking away the human interaction and so potential human error within there. And when we measure, particularly with the laser system, as you'll see in the demo, by measuring at the full cutting speed, we're encompassing all dynamics of the geometry that you're about to cut with. So we're taking all the thermal movements, any run out within the spindle, wear in the spindle, and we're going to incorporate all that into our measuring result.
Can I measure cutting tool wear?
Yes, yeah. With both systems that we're going to see, you can measure wear, breakage, and full tool setting.
David, we're about to see a 3D tool setting probe. What is it and what does it do?
It's a mechanical touch probe for setting of tools, which we call TC5420. The idea is that you can measure, set your tool lengths and radius on the machine in the machine process, and that's automatically uploaded to the tool offset files ready to start to use within the cutting program.
How does it do that?
You physically touch on the probe itself with the cutting tool. When the probe is deflected, it sends a signal wirelessly through an infrared link to the CNC control, and we capture the axis positions and do all the calculations within the software for calculating the tool length or the tool radius.
Okay, obviously if the tool's broke, we've had it, haven't we? But how about if there's a little bit of wear, what happens next?
It's down to how the software's set, really. Basically, you can set a limit of what is acceptable wear to you. If it exceeds that limit, then it will either just flag up an error to the operator to say, stop, something needs to happen, or if you want to stop the machining process, we can stop it, put an alarm on and stop your cutting straight away.
The laser technology, it's fairly new on me. What is it and how does it work?
Okay, yeah. Well, it's again a system for in-process setting, accurate setting of the cutting tool. It consists of a unit that's based on a transmitter at one end and a receiver on the other end, and then the cutting tool rotating at the speed that you're going to cut with goes through the laser beam, shading the laser beam, and we capture the axis positions and do all the calculations for length and diameter of the tool. But the beauty of the laser is we're measuring at the cutting speed, so what you're going to cut with is what we're actually measuring to get a true dynamic picture of the tool. And we can then do scanning, form control of all sorts of tool geometries. The limits are endless, really.
All sounds quite technical. What happens if we've got swarf flying around and coolant? How does it cope with the environment?
Yeah, this is a big question that people always come across with laser setting in machine tools. The big advantage of the Blum Laser Control NT system is the shutter protection system that's inbuilt into the system. Obviously, coolant going around the machine, swarf going around the machine, that's all going to affect your measuring results, and probably more importantly, you have to make sure that it doesn't infringe on the optics of the laser system, because once we start to contaminate the optics, then we will have issues. So that's what led us to develop the shutter system and incorporate it within the system. That's essentially a piston that's sealing the optics from the outside world when the machine is doing its machining operation. Then once we start a measurement, we actually open the shutters, start the measurement, and the NT function, which is a new technology function, microprocessor control of the laser, will handle all the coolant issues. So it knows where the cutting tool is supposed to be and avoids any coolant mismeasurements.
Blum Test, you're not the only manufacturer of lasers. How do the competition get around this problem?
Well, we're the only ones that actually use the shutter system, and our first generation laser we used literally just to blow air across the front, but we quickly realised that was just never going to be sufficient in today's machine tool. Now, as far as we're aware, that the competition are doing it by just blowing air across the front of the laser. One, you have the issue of the air consumption that is being used on the system, but also it just doesn't keep the optics clean enough, so you have to go in and manually start to, as part of a preventative maintenance, clean the optics. With the Blum system, you don't have to touch it at all. The shutter system completely protects it from the outside world.
Are these three products all that Blum Test offer?
No. These are probably three of the most common systems that we sell, particularly in the UK market. But we have an entire range and suite of in-machine, on-process measurement systems, and in fact, we also have our own measuring machine division within the group. So customers can come to us with bespoke requirements, and we can design solutions for their particular need. So the possibilities of what we can measure really are endless to the customer's imagination, I guess.